In this lesson, we'll be talking about some concepts from geometry, and we'll be using similar triangles to solve problems. Similar triangles have the same shape, but are not the same size. The corresponding angles, and that are those angles that are located in the same place when the figures are oriented the same way, will have the same measure, but the lengths of the sides can be different. And we'll use an equation called a proportion to find the lengths of unknown sides in similar triangles. Now this website will help us see how similar triangles work. So we'll go out there and take a look at that. So you can see here that I have two triangles that are shaped the same. You will notice that these indicators in each of the corners or each of the angles indicate that these angles are the same size or the same measure. But if I move one of the vertices or one of the endpoints, one of the corners, if you will, of the triangle, you'll notice that the shapes stay the same, that the angles are staying the same, but notice how it's recalculating the lengths of the sides. So this means that these are similar triangles. They stay the same shape because they have equal angles, but they don't have to have equal lengths. Now, if the lengths were exactly equal, we would call these congruent triangles. But because we're just looking at equivalent angles, these are called similar triangles. So here we have similar triangles. We can tell that because the angles are marked as equivalent. So the one line through means those are equal. 2 and 2, those angles are equivalent, 3 and 3. But obviously they have different lengths of sides. And because these triangles are similar, we can use proportions in order to solve problems. So let me show you how we could set up the proportions. And there are different ways to set these up. But notice, for example, that I have a little side S1 and then I have capital S1. Those are oriented and they're in the same position on the triangle when the triangles are oriented in the same direction. We could say that this ratio has to be equal to the ratio of S2 to capital S2 because it's the shorter side to the shorter side, the base side to the base side. And this is one of many proportions that we could use to find some of these missing sides. Now, as a quick reminder, if you have a proportion, A over B equals C over D, the products of the opposite top and bottom top have to be equivalent. So in other words, A times D has to have the same value as B times C. So we will cross multiply in order to solve, and then depending on which one of these sides we're looking for, we can divide both sides by that value. For example, if I wanted to find D, I could divide by A, and then these numbers over here, this calculation of B times C divided by A, could give me the value of the length of side D. Now this will make more sense when we do one with some real numbers. So here we have two triangles. They're similar. We can tell they're similar because they're marked this way and because we're told that they're similar. And now it asks us to use proportions to find the lengths of those missing sides, X and Y. So our first job is to orient them in the same direction so that we can, tell which sides will match up for the proportions. So now that I've done that, I can see that 10 is to Y because these sides correspond with each other. And I have a choice here. X is to 39, but that would give me two variables in this equation. So instead, I'm going to pick the 24 and the 36. So equals 24 over 36. So this is a proportion because we have these two ratios that are equal to each other. To solve, we do our cross multiplication. 10 times 36 equals 24 times y. And you can multiply two numbers in either order. That's called the commutative property. That will be 360. This will be 24y. And since we're trying to solve for y, we will divide by 24. And that will tell us that our value of y is 15. So this side is 15 feet, since the units indicated here, which are of course not to scale, but the units indicated here are feet. So now if I'd like to find the value of x, I can say x is to 39 as, and we can use the 24 over 36 again. Of course, we could also use the 10 over 15 because we now know that y is 15. If you cross multiply, you'll get 36x equals 936. That's what you get when you multiply 39 times 24. And when we divide by 36, we'll get that x is a value 26. Now let me show you sort of a quick check on this to make sure that you have everything right. These ratios have to be equivalent. So I've got 10 to 15. I've got 26 to 39. And I've got 24 to 36. If I reduce each one of these as much as possible, watch what happens. 5 will go into 10 and 15. 2/3. 13 will go into 26 and 39. 2/3. And 12 will go into 24 and 36. 2/3. So this is a property of similar triangles. Their sides are in the same proportion, and in this case, it's a ratio of 2 to 3. Now we're asked to use a similar triangle to solve a problem. We'll use similar triangles to find the distance across the lake. So here's our lake, and we know some of the measurements, but we don't know the measurement from B to C. So we're looking for the length of BC. That's that line segment from B to C. Now, it looks like there's just one triangle, but you have to remember there really are two. There's this big triangle, and then there's this smaller triangle that we have here. And it won't be drawn to scale, but I'll just draw it like this, 75 to 100. And then we've got 180 to our unknown here. So we can set up 75 is to 100. As this long unknown side, we'll just call it x, is to this long side 180. And now this is just one of different ways that you could set this up. We could have also said, let's see, we could have said 75 is to x as 100 is to 180. So we could have done this vertical side is to the vertical side as the flat side is to the flat side. I did small triangle is to small triangle as large triangle is to large triangle. So any of those ratios will work. You just have to make sure that you're matching up corresponding sides. If I cross multiply 100x And then 75 times 100 is 13,500. And if I divide both sides by 100, I get x is 135. Now let me show you that I could have set that up a different way and gotten the same answer. 75, that's the vertical side of the small triangle, is to our unknown, the vertical side of the large triangle, as the bottom side or the base side, 100 of the small triangle, is to 180 the base side of the large triangle. Now look at these numbers. 75 and 180 get multiplied, 100 and x get multiplied. So you can see you get exactly the same thing. You get 100x is 13,500. That's why you can do the proportions in different ways, but you do have to be careful to make sure that you are using the right sides when you're setting up proportions.